I've actually thought about aircraft designs for a long time, and I think there's an interesting opportunity to make like an electric supersonic VTOL jet.
The aviation industry is shaking. Rumors of Elon Musk's 2026 Tesla electric plane aren't just whispers. They're warnings to giants like Boeing and Airbus. A plane that's cheaper than a luxury SUV, silent in the skies, and capable of vertical takeoff? It sounds impossible, but Tesla says it's already real. What if this really is the end of Boeing's dominance? What happens when Musk unleashes a technology that rewrites air travel forever? And why is the US government suddenly backing him? Today, we'll expose the innovations, politics, and secrets behind Tesla's 2026 superplane and how it could crush the competition. Blueprints of disruption. For decades, Elon Musk hinted that his ambitions stretched beyond cars, rockets, and tunnels. Buried in interviews, tweets, and even offhand remarks at Tesla shareholder meetings were breadcrumbs of something larger. He admitted that he had sketched designs for electric aircraft years before Tesla was even profitable. He even described his dream of a vertical takeoff and landing jet that could fly supersonically on electric power alone. At the time, most dismissed it as one of Musk's endless thought experiments. But looking back now, those casual comments feel less like daydreams and more like blueprints. The so-called Tesla electric plane isn't just appearing out of nowhere. It's the product of a long, calculated build-up. Musk's empire, Tesla, SpaceX, Neuralink, Starlink, even the Boring Company, can all be seen as pieces of the puzzle. SpaceX provided access to aerospace-grade materials and composite manufacturing. Tesla perfected battery production and scaling. Starlink gave global connectivity. And AI breakthroughs, like the Dojo supercomputer, created the brain power for autonomous systems. When you stitch them together, the vision of a Tesla aircraft stops looking like fantasy and starts looking inevitable. The distinct characteristic of Musk's style is that it seeks to reinterpret the aviation supply chain. Aircraft manufacturing has been a complex, sluggish process going on for over 100 years, with hundreds of suppliers and layers of regulations involved. Hand-in-hand assembly of an airplane takes longer than one can say, "Make it a Tesla." Musk's resolve is to pull aviation kicking and screaming to the gigapress and factory-scale innovation. Just like Tesla changed car assembly by stamping huge sections of the car body in one press, the same idea is coalescing around fuselages and wing sections. Aircraft bodies can be manufactured in one shot, dematerializing assembly time and knocking costs down by 50%. It is not simply a case of prototyping for the rich. We are talking about scaling here. The Nevada Giga Air Plant, an offshoot of Tesla's Gigafactory concept, is being called a facility capable of rolling out 12,000 aircraft per annum by 2027. Now, for a perspective, the Boeing Airbus combine produces fewer than 1,200 commercial planes a year together. If Tesla were to pull even a fraction of that off, the waves it would send through the aviation industry would be seismic. For the first time, a private player untethered from legacy contracts, outdated practices, or bloated workforces will be able to foster the disruptions of cheap aircraft flooding into the market. Affordability is an ace in Musk's hand. While Boeing is busy with multi-million-dollar contracts from airlines and governments, Tesla has reportedly made the decision to set the price of its first aircraft at less than $80,000, which is cheaper than many luxury SUVs. A foundational redefinition of what air travel means. Musk is not trying to compete against the 747 and the Airbus A380. He is trying to bring flight to common businesses, private owners, flight schools, and entrepreneurs. Picture that. Air travel not as a luxury, but as a utility. But making a plane affordable is only the beginning, because Musk's biggest breakthrough solves the nightmare that has haunted electric aviation from the start. The weight war ends. If there was one problem that buried every electric plane project before it could even leave the hangar, it was weight. Ask any aerospace engineer what slays the dream of electric flight, and they'll point to the brutal math of batteries. Jet fuel gets burned off mid-flight, making planes lighter as they travel. Batteries don't. They stay heavy from takeoff to touchdown, and the numbers were devastating. To match the energy stored in the fuel of a Boeing 787, you would need millions of pounds of lithium-ion batteries, far too heavy for any craft to even get off the runway. That was the curse of electric aviation, until Tesla decided to flip the script. The solution came in the form of the StarVolt aluminum-ion battery, Tesla's biggest breakthrough since the invention of the lithium battery itself. Instead of struggling with outdated chemistries, Tesla built something entirely new. The StarVolt system stores 60% more energy per pound than the best lithium-ion packs in use today. Suddenly, instead of carrying a 4,000-pound pack for a modest range, Tesla's plane can cover 1,300 miles on just 1,984 pounds of batteries. That's half the weight of its rivals. In aviation, where every pound counts, this isn't just an improvement, it's a revolution. Musk showed us that engineering was not the only field he played with. He borrowed ideas from his company, SpaceX, and Cybertruck to rethink the way in which an airplane handles weight itself. Instead of concentrating really heavy batteries in one part of the fuselage, the Tesla plane works to distribute them evenly all throughout a carbon fiber exoskeleton. The same reasoning behind the Cybertruck being almost indestructible goes for aviation. Stress on the landing gear decreases by almost a third because of an even load across the body. That means softer landings, lesser maintenance costs, and no more jarring under the strain. SpaceX engineers also helped develop carbon fiber airframes that are, for the most part, 25% lighter than the aircraft's aluminum counterpart, with high tensile strength to withstand 6 times the aircraft's weight. The component shaves off another 600 plus pounds from the layout. The end result is a plane that is not crippled by its batteries, but empowered by them. Weight, in Tesla's eyes, went from being its greatest enemy to its biggest weapon. Then came a twist no one saw coming: energy recovery mid-flight. Just like Tesla cars recover their kinetic energy while slowing down, StarVolt batteries allow the aircraft to recover around 18% of its energy on descent. Imagine every landing getting the benefit of shedding 220 pounds of dead weight without carrying it in the first place. Added to a thermal stability that does not necessitate heavy cooling systems, the StarVolt design does away with hundreds of extra pounds from the aircraft and enhances safety. And since Tesla is as keen on speed as it is on efficiency, charging has become a non-issue. The packs can recharge 5 times faster than the lithium-ion cells, making a turnaround in 30 minutes possible. So this airplane not only flies, it can also fly repeated flights several times per day without being held back by the downtime traditionally associated with electric aviation. Solving weight is one thing, but convincing regulators that an electric plane is safe enough to carry lives, that's where Tesla faced its toughest battle yet. Safety that stuns the FAA. In aviation, you can have the most efficient engines, the lightest frame, and the longest range, but none of it matters if regulators won't let your plane leave the ground. Safety is the immovable wall every new aircraft must climb, and historically, it's where ambitious startups crash back to reality. The FAA's certification process is infamous for grinding projects down over years of red tape and impossible benchmarks. Yet, Tesla has somehow turned that gauntlet into its greatest proving ground. The first shock came during the StarVolt aluminum-ion battery trials. Conventional wisdom said that electric packs would always be a fire hazard, too unstable for aviation. Lithium-ion cells are notorious for overheating, swelling, and, in worst cases, igniting. But when Tesla rolled out its new chemistry, the FAA's own engineers were stunned. In stress tests simulating crashes, temperature extremes from negative 58 degrees Fahrenheit to 176 degrees Fahrenheit and vibrations equivalent to 12 times the force of gravity, the StarVolt pack didn't fail once. Even more impressive, its chemistry is 99.8% non-flammable. In an industry scarred by decades of fire-related disasters, Tesla delivered a battery that practically refuses to burn. In redundancy comes forth a second obsession in aviation, that aircraft must still fly while the major systems are failing. While the expectation of the world was that Tesla would go somewhat far, the confidence that says much more was needed to show Present's dual Starvolt packs in the 2026 plane. Two complete systems able to work independently and supply power to critical systems on board. If one of them is not functioning, the other one can keep the airplane in the air. Add quadruple redundancy on flight controls, and there lies the machine that can still deliver passengers safely, even while other systems have failed. Detractors had a good laugh when Musk promised that his plane would glide home in truly worst-case scenarios. Thanks to these layers of backups, that promise no longer sounds so delusional. The engineering never stopped at systems, rather, they redefined the meaning of physical safety. The cockpit itself is protected from external forces by the extraordinary Tesla glass Texas-born material capable of withstanding 5 times the aircraft's own weight. This has been specially engineered to allow direct bird strikes, hail impacts, and even debris impacts that would crack open conventional cockpits. On the other hand, Starvolt batteries are housed inside Kevlar-reinforced shells that absorb impacts equal to 1.5 times the energy required by prevailing industry standards. To put it plainly, Tesla designed a flying fortress, not just a plane. But the wildest step forward comes from the AI acting on Tesla's Dojo supercomputer. After training on more than 10 billion miles of Tesla road data and enhanced via SpaceX flight simulations, this AI does not just watch, it predicts. It predicts turbulence, weather change, and even potential mid-air collisions with an accuracy of 85%, greater than that of human pilots. The regulators call it predictive safety, a system that detects problems even before a pilot is conscious of their existence. It is revolutionary in an area where the vast majority of accidents are caused by human error to consider AI as a safety mechanism, not a hazard. But even with regulators convinced, one problem remains. Could Tesla's electric plane actually work in the real world of airports, airways, and everyday operations? From theory to takeoff. A certified design is one thing, but can it survive the messy, unpredictable reality of air travel? This is where most futuristic aircraft concepts hit a wall. On paper, they promise the moon. In practice, they're grounded by charging times, airport delays, weather, and logistics. For Tesla's electric plane to change the world, it had to prove that it could operate not as a novelty, but as a workhorse. And that's exactly what Elon Musk set out to do. The first game changer is charging speed. Traditional lithium-ion packs can take hours to recharge, making frequent flights nearly impossible. Tesla solved this with its mega charger network, adapted from the Semi program. At these stations, the Starvolt battery can hit 80% capacity in just 30 minutes. That turnaround transforms the plane from a weekend toy into a daily utility. Imagine a regional airline scheduling 4 or 5 flights per day per aircraft without downtime. For operators, this means higher efficiency, better profits, and no compromise on schedule. A great speed does not result in a great tarmac flight, as it needs a good distance. Tesla planes can fly a distance of 1,300 miles per charge, which is able to travel to point shores of US domestic routes: Dallas to New York, Los Angeles to Chicago. All these are suddenly converted to one-charge flights. Unlike fuel combustion airplanes, which require burning jet fuels in mid-air, Tesla aircraft maintain constant weight throughout, and thus are more predictable to the pilots and autopilot systems. Add regenerating descent, through which 18% of flying energy is captured. Then this aircraft not only surpasses expectations, but also rewrites them. Then, of course, an established surround puddle communications where the empire of Musk will really converge into. So, this is a Tesla plane operating on Starlink, SpaceX's constellation for satellite internet, that basically delivers real-time updates regarding anything from weather to turbulence to air traffic right into the cockpit with minimal lag. Airlines tend to record billion-dollar losses due to the weather during the year, so Starlink can give hope that we will reduce those interruptions by 25%. Passengers will also be winning through this as they access Wi-Fi-like speeds comparable to fiber connections found on the ground. Not just flying, but rather connecting the sky. The most daring innovation seems to be vertical takeoff and landing, VTOL. While Boeing and Airbus build traditional runways, Tesla intends to bypass them entirely. The electric motors, powered by Starvolt packs, would generate enough thrust for launches from rooftops and landings at city centers. It is truly revolutionary in convenience and not gimmicky at all. No more crawling through airports, security lines, and taxiways. Business travelers could lift off from downtown pads, soar above traffic, and land just minutes from the meeting. Early testing points toward the prospect of cutting urban travel times by 60%. For cities already saturated by millions, such as Los Angeles or New York, that's redemption. And the operational convenience goes even further, extending to maintenance. Tesla planes will also be built of components that have a legacy to EVs, so no oil changes, fewer moving parts, and modular batteries that plug in like Lego bricks would spell blessings for the practicality of just-in-time operation. It is a financial miracle for aviation to bring that time frame down to hours, especially when maintenance can ground planes for days. Downtime is less, which translates to more flights, and more flights will admit further adoption. Yet Tesla isn't just making planes practical, it's reshaping the passenger experience, turning every cabin into something aviation has never seen before. A sky built like a Tesla. If there's one thing Tesla understands better than legacy manufacturers, it's that people don't just buy vehicles for utility, they buy experiences. Just as Tesla cars rewrote the idea of what driving could feel like, the Tesla electric plane is designed to turn flying from a cramped chore into something sleek, intelligent, and even luxurious. From the moment you step inside, it feels less like an airplane and more like entering a living extension of the Tesla brand. The first thing passengers notice is the smart cabin architecture. Gone are the clusters of dials, switches, and overhead compartments. Instead, the interior is defined by clean lines, panoramic glass, and a central control hub that feels more like a giant Tesla dashboard than an aircraft cockpit. The plane's AI, powered by the same neural networks running Tesla cars and enhanced by Dojo's training, responds instantly to voice commands. Want to know your arrival time? Ask, want the cabin lights dimmed? Just say the word. Even navigation can be adjusted by simple voice input. Take me to Miami. Indeed, there is the pain of noise in aviation. Electric fans of Tesla, however, operate on magnetically levitated systems that avoid mechanical friction. Active noise cancellation built into the cabin walls reduces the sound profile to below 45 decibels at cruising altitude. That is quieter than a library, very much deafening, unlike conventional planes and, worse still, helicopters. Really, that too, the noise is reduced to less than 45 decibels at cruising altitude, which is quieter than a library. For them, that means that conversations can be made without shouting while they are talking on the phone, without the static used in conventional planes and helicopters. Instead, it feels more like floating. The seating experience is yet another avenue of advancement. Inspired by the Model X's ergonomics, the seating in an airplane consists of a lightweight carbon fiber shell wrapped with memory foam and capable of reclining and swiveling to provide lounge-like flexibility. Each chair will be biometric. It will automatically adjust things such as posture, climate, and lumbar support to suit the body's needs of the passenger. For business consideration, there are integrated wireless charging docks, magnetic mounts for laptops, and bone conduction speakers for private audio. For families, seamless Starlink connectivity is enabled for streaming, gaming, or video calling at 30,000 feet. The panoramic smart glass skylight overhead impacts the cabin environment. Tesla's electrochromic technology changes it from clear to dark, with a touch to react to direct sunlight. creating a tangibly calming environment during high-altitude flying. It does not only have a pretty face, it also helps diminish fatigue and jet lag by balancing natural light in real time. Coupled with Tesla's adaptive airflow system that quietly makes slight adjustments to cabin climate via hidden vents, the experience feels more akin to a spa than an aircraft. Safety is already built into the cabin experience. Harnesses for every seat are automatically tightened by the plane's AI system when turbulence sets in, while personal screens provide clear visual instructions in case of an emergency. Blues or reds come through the lights, depending on the situation, helping the passengers remain calm and informed. Even storage for luggage is transformed. A cabin free from overhead bins is achieved thanks to the storage compartments integrated under and behind the seating. It doesn't take you from place to place in a straight line. It takes you beyond that. Flying in a Tesla airplane feels like walking into the future of mobility, silent, connected, comfortable, and smart. And here's the twist to keep Boeing and Airbus top executives awake at night. All of it at a price lower than a loaded Ford F-150. Not only has Tesla matched the giants of aviation in offering luxury and performance, but it has also gone ahead with the same and delivered an out-of-this-world cabin experience that these companies never dared to imagine. Tesla's 2026 electric plane isn't just an innovation. It's a revolution that could topple the giants of aviation. From crushing the battery weight curse to building cabins smarter than homes, Musk has delivered a vision that feels unstoppable. If this glimpse into the future of flight blew your mind, hit like, drop a comment with your thoughts, and subscribe for more. And don't miss the next video on your screen, because the race to the skies has only just begun.